Hey everybody, we're talking enthalpy, entropy, and spontaneity in video notes 10.2. Alright, so you know the driving forces of a chemical reaction, and we're going to learn about H, S, and G. Alright, so what does spontaneous reactions mean? Here's the definition. A reaction is spontaneous if it proceeds on its own without outside intervention. It has naturally favorable conditions at some temperatures. So spontaneous doesn't mean, well, let me give you two examples. Okay, so this is going to rust spontaneously, and this is going to melt spontaneously. But wait, it actually does depend on temperature for both of them. Okay, so this isn't going to melt if it's over 0 degrees Celsius. Right? I mean, sorry, this is only going to melt if it's over 0 degrees Celsius, but that will be spontaneous at that temperature. Okay, and this happens at a certain temperature too, but it's spontaneous. We don't have to do anything to do it. We don't have to intervene. Spontaneous, oh my gosh, spontaneous doesn't mean rapid necessarily. Okay, so it could be slow or fast, like that snail, super fast, right? Or not. It doesn't mean it's explosive. It's spontaneous. Okay, you could have a slow spontaneous reaction. You can have a non-explosive spontaneous reaction. So spontaneous doesn't mean rapid or fast, although it could. Outside intervention. What does that mean? Well, so spontaneous reactions happen naturally, but they might need an initial spark. We already know what that initial spark is called. It's called activation energy. So, even though some reactions are spontaneous, they might need a spark to get over, to break them, so that they can make them. Okay, so get over the activation energy barrier. That was what the spark's for. But once it's got that initial spark, the reaction will continue as long as there's reactants available. Okay, so non-spontaneous can actually happen, but it takes a lot of extra work for the people who want it to happen. All right, so what's spontaneous here? All right, this is spontaneous. This is not. So if you want a non-spontaneous thing to happen, it takes a heck of a lot more energy and work to ski up the hill. Okay, so spontaneous is a natural occurrence in a favored direction naturally. So what determines it? Enthalpy and entropy, two E words, because why make them other than E words? So let's talk about enthalpy again. Enthalpy is H heat. Oh, look at that. Delta H enthalpy heat. See that again. Delta H enthalpy heat. Remember that for EVs. Okay. It's one of the driving forces for a reaction. It's the heat content of a reaction. And naturally favored conditions that for enthalpy are negative delta H. So negative delta H is a naturally favored condition, favorable condition, promotes spontaneous reactions. It doesn't necessarily mean they will be spontaneous, but a lot of spontaneous reactions are exothermic. Okay, so when the delta H is negative, it's exothermic. You go low on your energy diagram, but you still might need to activate with a spark. Okay, going low is more stable. That's why delta H negative is favored in nature, because it makes more stable products. Okay, so some endothermic reactions are actually spontaneous. What? So in order for an endothermic reaction to be spontaneous, there has to be an increase in entropy. So you're saying to yourself, she said increase in entropy. What does that mean? Let's drop you right into the next slide with entropy. Entropy is a measure of the disorder or randomness of a substance. Okay, the more different ways a substance can be, the more random it is. What does that mean? Okay, so the symbol is S, because that has nothing to do with the word entropy. It's totally random, right? S is random, so the symbol for entropy is S. All right, that is totally random. Nothing gets done there. All right, so delta S is entropy. The favored condition that promotes a spontaneous reaction is increase in entropy. The universe is going towards more entropy. A spontaneous process will happen, will be more likely spontaneous if there's a energy spread or an increase in entropy. Okay, more random is a favored condition. So what are some? Here's a more favored condition, because the gas molecules of H2O are a lot more random. There's a lot more different ways those gas molecules can be arranged than they can there or there. So this is less S, this is more S. Okay, more randomness in a gas than a solid or liquid. Okay, delta S is entropy is disorder. Check that out. SS, SSSS. So this is more ways. Those particles have lots of different ways. If we took a picture of them where they could be arranged, it's much more random. This is less random. This is the most structured, so that's the least entropy. Okay, so there's really 4 things you should know about increased entropy. If in a chemical reaction gases are formed, or even in a physical change, if gases are formed from liquids or solids, increased entropy. A way to represent that is gases turn into, other way around. More randomness is a solid or a liquid turning into a gas. That is more random. Solutions are formed, so solids or liquids turn, or gases even, turn into aqueous. Right? There are more gas particles in the products than there were in the reactants. So if we have 4 gas particles on this side, on the other side we have 5 gas particles, then there's more randomness in 5 gas particles. Or if the temperature increases. So we'll look at these conditions in practicing. Okay, here's a visual of what I just said. Look at structure, random, positive delta S. Structure, random, positive delta S. Structure, random, positive delta S. System at a low temp, system at a high temp, positive. It's more random with the higher temperature molecules. Okay, so the laws of thermodynamics we're not going to get into too much, but the entropy of the universe is constantly increasing. All right, so you finally have an excuse for your messy bedroom or exploding locker or folder. It's nature's way. I wouldn't try that if you don't want to clean your room. You might get stuck cleaning and get grounded for being a smarty pants. Okay. So, enthalpy and entropy together predict whether a reaction is spontaneous. If you have increased entropy, that's positive delta S, that's favored, that's a naturally favorable condition. Decreased enthalpy, that's exothermic, favored condition. Those two together will always make a spontaneous reaction. Why? New term, they release Gibbs free energy. What? They release Gibbs free energy. So now I got to tell you what that is. Gibbs free energy is delta G. Right? There's a formula, mathematical way we can calculate it. Gibbs free energy is delta G. Okay, so delta G is one thing if we could decide if something's spontaneous or not. So delta G is spontaneity. If delta G is negative, the reaction is spontaneous. If delta G is positive, it's not spontaneous. If delta G is 0, it's at equilibrium. Okay, so the forward and reverse reaction are happening. Okay, what is Gibbs free energy? It's energy free to do work. So why is a negative G spontaneous? Because that is free energy released out into the environment to do work for something else. Okay, so here is how we're going to calculate H and S. We did H in the last video notes, so we're doing S here, but look, we have a table. Okay, so here's the delta S values, here's delta H values, and here's our substances. So, oh, look, it's the same calculation with S's instead of H's. So if we want to calculate the delta H for the S for this, we'd look up silver's delta S. Silver is negative, is 0.0426. So 0.0426. Right? But then we have to multiply that by 2. Okay, let's look at for chlorine. Cl2, 0.223. 0.223. All right, and then silver, solid silver chloride is 0.096. 0.096. But again, we have to multiply by the moles. Okay, so then 2 times 0.046 is going to give us 0.0852. All right, 0.223, 2.96 is going to give us 2 times 0.096 gives us 0.192. All right, but then remember we have to do the sum of the products minus the sum of the reactants. So the sum of the products is 0.192. We added them up minus the sum of the reactants. So yeah, 0.08. Let me double check that one. 2 times 0.0426 is 0.0852. I did it right. Okay, so 0.0852 plus 0.223. All right, and then we subtract all that. So 0.192 minus 0.0852, which was added to 0.223. Close that, and I get negative 1162 points. All right. Now, what units are on those? Well, look, it's kilojoule per mole Kelvin. All right, but we cancel out our moles because we multiplied. So kilojoules per Kelvin. Kilojoules per Kelvin. Okay. So, well, oh, wait a second. No, I think I did it right. That added those together on this side. So that's the reactants, and that minus that. So this is negative delta S. What does that mean? That means entropy goes down. Well, let's look at this reaction again. Solid and gas turn into all solid. That's getting less random, so the negative, we will predict this to be a negative change, and it is a negative change. So now what do we do? That's how you calculate S, just like you calculated H. So you need to be able to calculate all three of these things. So delta H, you do products minus reactants after you add them up. Delta S, products minus reactants after you add them up. And delta G, we're going to take into account the change in H and the change in S plus the T. Let's look at that one. Okay, delta G is Gibbs free energy. Delta H is the heat of the reaction. T is the temperature, has to be in Kelvin. And delta S is disorder or entropy. Okay, so we have to plug all those into our G formula. Right, so here we have a system that has a temperature of 298 Kelvin, an enthalpy change, H, of negative 223, and a delta S of positive 0.035 kilojoule per Kelvin. What's the Gibbs free energy? Oh, so we need to find G. So we plug in delta H, 223 kilojoules, minus the temperature, 298 Kelvin, times delta S, which is 0.035 kilojoules per mole. Hey, look what happened. I said mole, I meant Kelvin. Look, Kelvins cancel. So you have clear that, negative. Oh, it's not point. Negative 223 minus, parentheses, 298 times 0.035 close equals. The answer is negative 233.43, and that's going to be kilojoules of energy. So delta G is negative. What does delta G negative mean? It means it is spontaneous. Yes. Why? Because delta G is negative, which means free energy. This much free energy is released into the system after that chemical process. Okay. So when is the reaction going to be spontaneous? Well, there's different conditions. What if the delta H is negative and the delta S is positive? This is naturally favored, so is that. So what's going to happen? This will always be spontaneous. That means automatically that, we'll get to that in a second. So if this is spontaneous, then delta G is going to be negative. Okay. If delta H is positive, nature doesn't like that. If delta S is negative, that means it gets less random. Woo. So is that going to be spontaneous? No. So that means the delta G is going to be positive. Slow down, Herbs. Okay. Next case. Hey, delta H is negative. That's what nature wants. Exo. Delta S is negative. Nature doesn't want it. So those two conditions are not both favored by nature or both not favored. So guess what? It may be spontaneous. It's going to have to depend on the temperature. What if the reaction's endothermic? Oh, nature doesn't want that. But nature does want more randomness. So this is another maybe case for whether the reaction is going to be spontaneous. So, yes, spontaneous means negative delta G. No spontaneous means positive delta G. Okay. What happens when there's a maybe? We have to calculate, and it really will depend on the temperature of the reaction. Okay, so if delta G is negative, that means it's spontaneous. There's free energy released. That energy released, the negative G, is able to do work. Okay, positive value means it's not spontaneous because you have to add free energy in to do it. Delta G equals 0 is equilibrium. Both the forward and reverse reaction occur at the same rate. That's our next chapter. Woo! Okay, so to review, we needed to, okay, so things falling out of the sky would be spontaneous, okay? All right. Enthalpy is H, entropy is S. They help us determine the spontaneity, or G, Gibbs free energy. You have to calculate H and S. Make sure to do sum and then products minus reactants. Favored enthalpy is negative. Favored entropy is positive. Be able to calculate G using this formula. All right. Entropy is disorder, and we have to count gases a lot. Okay. Change in state helps too. Change in state. We'll practice. Okay. Gibbs, delta G is Gibbs free energy. Negative means spontaneous. All right. Okay. So 1, 2, 3, 4, 5, 6 bullet points here. Did we do it? Maybe. We just have to practice to see if we really know it. Spontaneous. Free energy released. Thanks, Tom. Peace out.